Okay, today's lesson is on trig ratios of any angle and radius length. Now, real quick recall, the sine is equal to the opposite over hypotenuse. Cosine is equal to the adjacent over hypotenuse. Tangent is equal to opposite over adjacent. And something that we're going to need for today's lesson is the Pythagorean theorem. And remember, on a right triangle, square of the sides, the sum of the square of the sides is equal to the square of the hypotenuse. A squared plus b squared equals c squared. So what we want to do is evaluate the function given a point on the terminal side of the angle. This is the exact same directions as your homework, so follow this and it'll help you get through the homework. Simplify, rationalize if necessary. What that means is if you have a radical in the bottom, then we need to fix it. All right, so our first example, I have an ordered pair, -3, 4. Right, I want to evaluate the function sine. We'll say sine of theta. So the first thing I want to do is draw this ordered pair. So this ordered pair would be in quadrant 2 because I go left 1, 2, 3, and then up 1, 2, 3, 4. So this angle will pass through that point. All right? So what I do is I draw a right triangle, I draw down to the x-axis, because I want theta always to be with the origin. And if I label this is -3, this is +4. And I know by definition the sign is opposite over hypotenuse. Well, opposite of theta is the 4. The hypotenuse is over here. But if you remember from geometry, this is a 3, 4, 5 right triangle. If it's not a special triangle, it's called a Pythagorean triple, and I'll give you some more in a few minutes. But now all I need to do is state the sign of this answer. The sign is opposite over hypotenuse, which would be 4 over 5. Now we learned in an earlier lesson that in quadrant 2, all your x's are negative, but your y's are positive. And remember, your cosine, your sine. So your sine is positive, and it is. I get 4/5. Next one. Again, it passes through the point 5, -12. But this time I want to know, what is the tangent? What's the tangent of the angle that passes through, or the angle that has a terminal side that passes through there? Because technically theta is this right here, but I can still draw a right triangle. So the same thing here. So it'd be 5, -12, which is going to be in quadrant 4. So 5, -12 is way down here. And I connect that to the origin, and I draw it back to the x-axis, which makes this a right triangle. The x value is 5. The y value is -12. Now, this is another one of those special triangles. It's called a Pythagorean triple. And I'll show you if you don't know that, you can find the missing side by squaring the two sides, adding them together. So I get 169. Now this is going to equal to the hypotenuse squared. So the hypotenuse is the square root of that. So the hypotenuse would be 13. So this is one of those Pythagorean triples. It's a 5, 12, 13. That's nice if you know that. The hypotenuse is always positive. So I don't really need that. I found it anyway just for practice, because the definition of tangent is equal to opposite over adjacent. Well, the opposite is this, -12. The adjacent is the 5. So I really didn't need the hypotenuse, but we're going to need another one, so I'll just show you how to find it. So it'd be -12 over 5. So the tangent of theta again is always with the x-axis, is -12 over 5. So what are these Pythagorean triples? Here's a couple of them. 3, 4, 5 is a Pythagorean triple. And actually any multiple of that. So if I multiply that by 2, that by 2, that by 2, but 6, 8, 10. Another Pythagorean triple is 8, 15, 17. And one more. And again, any multiples of these. 5, 12, 13. Nice if you knew those. We could save some time. You wouldn't have to find this hypotenuse. It's a Pythagorean triple. All right, number 3. -3, 5. And I want to know the cosine this time. Again, step number 1, draw a point and make a right triangle from there. So -3, 5 is over here in quadrant 2. We'll say it's up here. There's -3, 5. Draw down to the x-axis and then to the origin. This is my theta. Label your sides. This is 3. This is 5. Or -3. I'm going to leave that there. This is not a 3, 4, 5 right triangle because the hypotenuse has to be the largest side. So I take my 5 and square it. And technically, I only need to take the 3 and square it because we're dealing with lengths. But it wouldn't matter. And that's going to equal my hypotenuse squared. So I get 25 plus 9 is the hypotenuse squared. The hypotenuse squared equals 34. So the hypotenuse then would be the square root of 34. Simplify if you can. There's no perfect square in there, so this is the square root of 34. And the definition of cosine is adjacent over hypotenuse. The adjacent side is this side here. The hypotenuse is over here. So that would just be -3 over the square root of 34. And this is why I put these directions, rationalize if necessary. This is necessary because we don't want to have a radical in the bottom. So I multiply the top and the bottom by the square root of 34. We've done that before. So it's -3 times the square root of 34 over 34. And I know from what I said from problem number 1, the cosine is negative in quadrant 2. And it is. But if you label these with the values here, positive or negative, it'll all work out for you. All right, so if we have another one, we have the ordered pair 2, 3, and I want to know the sine of theta that passes through that point. This one's going to be in quadrant 1, and right away I know my enter has to be positive because sine is positive in 1, positive in 2, negative in 3, and 4. So over here I have a point 2, 3. Draw down to the x-axis, draw to the origin, label your sides. This is 2, this is 3. It's not a Pythagorean triple, so I'm going to have to find the hypotenuse. The hypotenuse squared from the Pythagorean theorem is equal to 2 squared plus 3 squared, which would be 4 plus 9, or 13. So the hypotenuse, remember, is the square root of that. And by definition, sine is opposite over hypotenuse. So the sine of theta will equal opposite over hypotenuse. But we can't have that radical in the bottom. I multiply the top and the bottom by the square root of 13. I'll get 3 times the square root of 13 over 13. Last type of problem. Suppose I said that the sine of theta is greater than 0, but the cosine is less than 0. What quadrant would this be in? Well, I know that the sine is positive in 1 and 2. Because remember, your sine is your y, your cosine is your x. So down here it would be negative, negative, and here positive, negative. Your sine is your y, cosine is your x. So sine is greater than 0, it just means positive in 1 and 2. Cosine less than 0 is negative. Cosine is negative here and here. Well, all you're looking for is where they overlap, and they overlap in quadrant 2, so this would be quadrant 2. Okay, this should be enough to help you get through the homework. Good luck, and as always, have fun.